The title of my work is Robust Battery Rotation Estimation for Industrial Robotics using OpenCV Template Matching. This study aims to develop and validate a vision system for detecting the rotation of a CR2450 battery in an industrial PCB assembly process. The proposed method integrates image processing techniques, feature extraction, and template matching to enhance the accuracy of rotation detection. Our purpose is to develop an accurate and efficient computer vision system using the library OpenCV and Python for detecting battery angles inside of a robotic industrial automation process, ensuring an error smaller than 2 degrees. In automated assembly processes, the position components autonomously require precision and speed, and the automation process must be flexible to absorb variations. Robots are widely used in tasks such as assembly, welding, quality inspection, and material handling. They are robust and flexible, reduce operating costs, and increase productivity. The use of a camera and computer algorithm is a low-cost and highly sophisticated method that offers a way to collect information and parameters in real time. The template must be smaller than the search image and is going to be rotated, so to avoid empty spaces caused by image rotation, before the correlation calculation step, the template was reduced by 45%. The angle search process consists of sliding over the search image with the standard template, looking for the highest cross-correlation index, rotating the template by 0.5 degrees per step, ranging from -5 to 45 degrees. The algorithm achieved an accuracy of approximately 77.1% within acceptable values for the production process, with a maximum variation of 2 degrees. The results obtained shows the efficiency of the algorithm in predict angles. Although there was a variation in the predicted values compared to the real values, especially in the ranges of 0 to 10 degrees, the analysis of the discrepancies between the predicted and real values revealed that the algorithm is sensitive to lighting and scale, which affects the accuracy at lower angles. From the error histograms, it was observed that most of the errors were concentrated in variations smaller than 2.5 degrees, suggesting that the algorithm has a more robust performance within this error range.